An action potential arrives at the synaptic terminal releasing acetylcholine. As acetylcholine binds to receptors, it creates a new action potential that travels along the sarcolemma and into the muscle.
The action potential will then reach the T-tubule, which will activate the sarcoplastic reticulum to release calcium molecules, which will eventually travel to the myofibrils. These calcium molecules will then bind to troponin, which activates a change in it. This change causes tropomyosin to move, exposing the binding sites. ATP is then hydrolyzed into ADP, an inorganic phosphate, which energizes the myosin head to hook onto the binding site and create a cross bridge. The myosin head then pulls the Z line and the actin towards the center of the sarcomere. This action is called the power stroke. ADP and phosphate are then released, and a new molecule of ATP binds to the myosin head. This allows the myosin head itself to release from the binding site. ATP will again be hydrolyzed into ADP and an inorganic phosphate, and the whole process will repeat itself. However, if there are no more action potentials generated, no more calcium will be released. Then the enzyme acetylcholinesterase will remove acetylcholine from the motor end plate, and all action potential transmission on the muscle fiber will end. Calcium will then be transported back into the sarcoplasmic reticulum. Tropomyosin will once again cover the binding sites and block myosin heads from attaching to them, and the myofilaments will slide back to their original positions, and the muscle fiber will relax.